In this video, we're going to explore when variables are created, how long they exist in computer memory, and what happens when two variables have the same name in two different functions. Here we see function convert_to_minutes, which we explored in the function visualization lecture. We have added function convert_to_seconds, which converts a number of hours to an equivalent number of seconds. Convert_to_seconds does its work by calling convert_to_minutes, and then multiplying the result by 60. Let's use the visualizer to explore this. We'll quickly step over the function definitions. Two function objects are created. Convert_to_minutes refers to one of these function objects, and convert_to_seconds refers to the other. Now we are about to execute an assignment statement. The first step is to evaluate the right-hand side, which is a function call. Python first evaluates the argument and creates an object for that value. Next, Python creates a frame on the call stack and stores the memory address of 2 in the parameter num_hours. As a reminder, this area is called the call stack. It is shown as an upside-down stack of frames. During execution of a function call, a new stack frame is created. Whenever a function exits, the current stack frame is erased, and execution of the previous function continues. The first line in the body of convert_to_seconds is another assignment statement. The right-hand side is a function call. We follow the same rules as always. Evaluate the argument num_hours, which contains the memory address of value 2. Then, a stack frame is created for the call on convert_to_minutes, and its parameter num_hours contains the memory address of that value. There are two variables called num_hours. One of them is in the frame for the call on convert_to_minutes, and one of them is in the frame for the call on convert_to_seconds. Python keeps these two running functions in separate areas of memory, so it does not get confused about which variable to use. Back to tracing the execution. The first line in the body of convert_to_minutes is an assignment statement. On the right-hand side is an expression num_hours times 60. But which num_hours do we use? The answer is that Python looks in the current stack frame. Num_hours refers to 2, so num_hours times 60 evaluates to 120. The second step of the assignment statement is to assign 120 to variable minutes. If minutes does not exist in the current stack frame, then it will be created. Each stack frame contains its own set of variables. In the frame for convert_to_minutes are variables num_hours and minutes. The frame for convert_to_seconds currently only has variable num_hours, although by the end of its execution, it will also have both minutes and seconds. The stack frame for the main program currently has convert_to_minutes and convert_to_seconds, although by the time the assignment statement on line 20 is done executing, variable seconds will exist there. We're now about to return the value of variable minutes and exit the current function, but where do we return to? The answer is always to the next frame on the call stack. The current stack frame was created during this call on convert_to_minutes. When this call is complete, the current stack frame is erased and Python produces the return value as the value of this function call expression. This call is on the right-hand side of an assignment statement. To complete the assignment, variable minutes will be created, and Python will store the memory address of the return value. Let's watch that happen. Notice that the frame for convert_to_minutes has been erased, and variable minutes has been created in the frame for convert_to_seconds. Here we have another assignment statement. The right-hand side, minutes times 60, evaluates to whatever 120 times 60 is, and a new variable seconds will be created and contain the memory address of that new value. Next, we return seconds. Seconds refers to 7,200, so that's the value that gets produced by the call on convert_to_seconds on line 20.